Okay, good afternoon, everyone. So as you are joining us, you can just type up your name so that we know who is with us. So as we give a minute for those that want to join us, you can basically type up your name so that we know who is with us. Yeah, and let me know if I'm audible enough. So if you're able to get me, type up yes, we are able to get. Yeah, so if you're able to get me, type up your name. As you join us, you can type up your name and let me know if you're able to get me. If I'm audible enough, let me know. Okay, good. So you can type up your name, and basically share the link to your friends so that they can join as well. So I'll give a minute or two for the people to join us so that we can start together. Okay, Moses Zimba. Yeah, so type up your name and share the link with your friends so that they can join, so that we can start together. Okay, so today we are going to do set theory. So we are going to cover some concepts that we did do in class will be covered today. So most of them will be part of revisions for those that have been attending classes, and then for the new members, this is your time to basically catch up what you missed under the same topic called set theory. So we are going to do set theory. Okay, so this will be our topic for today. Yeah. Okay, so we can start. So if I may ask, what is a set? So a set, if I to define a set, is a collection of objects are called elements. So if you have a set, how can you define a set? A set is a collection of objects called elements. So objects in a set are called elements. So anything, if we can have maybe a set of pens, a set of whatever you can have, but if you put them together, we can make a set. And then if you put those objects in a particular set, we call them elements. So this is the definition of a set. So we're going to go direct to focus on what's important and examinable stuff, or rather what you need for you to handle questions that they basically ask in your tests and exams. So first thing, we need to understand the common symbols that we use under sets. So we have what you call common symbols. So common symbols used under sets. Yeah. So we can have number one. If I put a symbol here, let's say we have this. So this symbol is called intersection. And we all know what it means, intersection. If intersection meaning we are trying to find the common elements between two sets. For example, if I've got set A to be given maybe 1 and 2, and set B, let's say our set B is basically 2. So the question might come, find A intersection B. What we mean here that we have to list the elements that is found in both set A and set B, meaning the intersection means elements that are in both two sets, like if I have set A and set B. So if I say A intersection B, I mean, can you list the elements that are in both set A and set B, of which our answer here is going to be 2. So 2 is in both set A and set B, meaning this is what we have. So that's our first symbol. So second symbol will be this one here. So this is called union symbol. So union is basically putting together two sets. For example, if the same set we gave as an example, if I say, can you find A union B? What I mean, you have to list all the elements that are in set A and set B. So our answer will be 1 and 2. Because we should know that we don't write one number twice. We know that 2 is in set A and 2 is in set B, but when putting A union B, we just write 2 single. Yeah, because we already know that is in both. And then number 3, we can have a symbol, this one here. This means member of. Member of, yeah. So then the fourth one is basically simple, which is here, meaning this means not a member. Not a member of. Meaning we are talking about elements that are not a member of a certain set. Then this one is represented or is given to talk about the particular elements that belongs to a particular set. Meaning those elements are a member of that particular set. For example, we have 1 and 2. 1 and 2 are the members of set A. Again, 2 is a member of set B. But we can say that 1 is not a member of set B. Meaning this one can be used to describe 1. Because 1 in this case is not a member of set B. Yeah, so other symbols that we should know is basically we can have A or rather U. So this means universal set. Okay, so universal set. So universal set is basically the mother set of all the elements. So we can have set A and set B. Now we can have the mother set to which all the elements in A and B are derived from. So that's the universal set. So from the word universal, meaning it's a main set to which all the elements given belongs to. Then we can have another symbol which can be, okay, we can have this one here, which looks like a C. So this one is called subset. So subset. Okay. Subset. So for example, if I have D is a subset of let's say B. What does this mean? Which one is a minor set? So the first one mentioned is always the minor set, meaning the last one mentioned is the bigger set. Okay? Yeah. So how can you write it? Diagrammatical representation. So in diagram, it can be written like this. Another set inside. So meaning our D is the set which is inside the other set. So D is here, then our B is outside. So by definition, we can say a subset is a set within another set. So we have a set and then another set inside. So if I say D is a subset of B, what I mean that all the elements that are in set D are in set B. Okay, so for example, we can have our set B to be equal to maybe 1, 2, and 3. Then our set D to be equal to, let's say we have maybe 2 and 3, meaning we have 2 and 3 here, then I'm going to have a 1 here. So what we have here that this is set B and this is a circle for set D. For set B, we have elements 1, 2, and 3. And then our set D, I've got 2 and 3. Meaning that set D is within set B. So we can say that D is a subset of B. So always the first letter mentioned is a minor set. The second letter is a major set, or the one outside, covering the other one. So let me know if you are together so far. So you can type up we are together or just say yes, we are following, so that we bring out other concepts that you basically need to know. So are we together so far? Are we together? So just let me know if we're together so that we basically move on. Okay, so okay, so all right, we can move to the next concept that you need to know as we begin this. So next concept that you basically need to know is we have to talk about some of the laws of sets, and then so we have what we call laws of sets. So number one, we have what we call commutativity or commutative law. So just all you need to know is what it states or what its mathematical operation or mathematical expression of commutativity law. So this one says that if you have A intersection B can be equal to B intersection A. So what we have done here basically is just to swap. In the first case, we have A as the first letter or the first set. We try to intersect with its B. Then this side we swap B to be the first one and then A to be the last one. So meaning according to commutativity law, A intersection B is equal to B intersection A. So this is the first one. Then the second commutativity is where we say A, we try to use union B, should also be equal to B union A. So these are the two commutativity laws of sets. One for the intersection, the other one for union. So this is all you need to know what it states. Then number two, we have what we call associative. So associative law. Okay. So associative law states. So all you need to know is what it states. Good. So we can have A, B, and C. Then this can be equal to A, B, and C. Then if we use intersection and intersection here, another intersection. So for associative, if in the first case, I put A and B in brackets, then the other case, I try to change to put the last two in brackets. It has to be equal as well. So this is the first associative, meaning there is an association between these three sets, A, B, and C, meaning that in the first case, A can associate with B, and B can associate with C. Okay? So we're trying to find association between the three sets. So meaning that A intersection B in brackets intersection C should be equal to A intersection open bracket B intersection C. So this is the first one. So we can say A, and then B is where we use union. So we have A union B union C. This is can be equal to A union B and union C. So it's the same thing. I can put these two guys here, and then this side I do this. It has to be equal. So this is associative law. So there is associative law of intersection and associative law of unions. So this is all you need to know, a law and what it states, or its mathematical expression. Yeah. Then number 3, we have distributive. So distributive. So distributive law of sets. So we also have 2 here. Yeah. So the first one is where we have, if we have A, intersection. So this one you have to pay attention to distributive law. Open bracket, then we can have B union C. So pay attention here. Then this can be equal to, so this is the first case, you have A intersection. So you have to see the difference here. In associative, for each statement, we're only having a single symbol. Here, if it is intersection, it will be intersection throughout in that expression. Even if it is union, it's union throughout. But for distributive, you see, it's a combination of intersection and union in one expression. So we have A intersection, then B union C. It has to be equal to. So, before we go any further, if I were to give you something like this, if I have 2 multiplied by x plus 4, what it means here is that these two with the sign multiplication sign, so it's 2 times x and 2 times 8. This is what it means, right? Meaning that this can be equal to 2 with a sign times x, then we say plus, right? The plus sign which is between the 2 numbers inside the brackets. So we have 2 outside and the sign multiplication outside. Then inside the brackets we have x plus 4. So what it means is that the 2 is basically multiplying the 2 things inside the brackets. So now that I'm saying that this is the same as 2 times, which is here, x. We get this. At the same time, 2 times, which is 4 here. So can you see this one? Yeah. So this is what we have. We have an idea of this particular statement. Now let's come back to this one here. So we have A and the intersection outside. Then inside the brackets we have B union C. So what it means here is that A intersection is basically multiplying what is inside the brackets. So at first the A intersection should go with B, and then A intersection should go with C. Okay, so this can be equal to A intersection, which is outside here. Then we can say intersection B in the first case here, which we have here. Meaning we have done A intersection B. Now the separating symbol between B and C is basically union. So we can put our union here. So we can say in brackets this one so that we look smart. Then we come to the other one. So to be A intersection C. So to be A, then intersection, the next letter which is basically C, then we do this. So this will be our first distributive law, where we say A intersection, what is inside the brackets. So make sure that you know this one very well. Even if we are to forget beta, you forget commutativity, but don't forget this one. So this will be our A, and then our B property will be the one for A union, and then B intersections. So yeah, intersection C. Okay, so it's the same principle we have from doing. So it is A union, which is outside here. So to be A union, then we get B. We do that. So now we follow what is the separating sign between B and C. It's basically intersection. Then we come back A union from outside, intersection C. So this is what we have. So meaning we have the first one, A intersection B union C. It will be equal to A intersection B union A intersection C. Then the other one for union is A union B intersection C, meaning this will be equal to A union B in brackets, then intersection A union C in brackets. So this is very, very important. Never should you try to forget the distributive law of sets. Okay, so let's move to the next concept, that is now the properties of the sets. So these are the major laws of sets that you need to know for you to be able to simplify any given set. So you need to know this one, especially distributive law. Very, very important. Okay, so let's move to the properties of sets. So we have what we call properties. So properties of sets. So under properties of sets, also very, very important to know. So the first property is what we have, that if I have A intersection A, what would be the answer? Meaning, what could be the intersection between set A and set A? If we give an example, if we have in set A, we have got, if our set A is basically this, 1, 2. What could be A intersection A? It's basically the same set A. So if we intersect the set with itself, the answer is the set itself, right? So meaning the answer is basically A. So intersecting a set with itself, the answer is basically the same set. Okay? Yeah. Then number 2, if we have A, intersection A complement. What is the answer? Then in this case, we are trying to find an intersection between element in set A and element outside set B. Oh, sorry, element in set A and elements outside set A. There should be no intersection, because if an element is not, because we know intersection is basically finding common elements between two sets. The elements found in this set and in another set at the same time. So if you have A intersection A complement, what we mean here is that we are trying to find the intersection or element found in set A and outside set A. So in this case, the answer is basically empty set. We can't find a common number between element inside A and element completely outside A. So number 3 property is where we have A union A complement. So if you have A union A complement, these are the same sets. Meaning in this case, we are trying to list the elements inside A and elements outside A. For example, if we have this as a Venn diagram, and then set A is here. So let's say inside A we have 1 and 2, and then we have in the Venn diagram we have, let's say, 3 and 4. So if I have to list what is A complement, A complement is basically elements outside A, which is 3 and 4. Yeah. Then what is set A? Set A is what we have here. So in the first case, we said find A intersection A complement. So this is A complement, this is set A. Do you have n element in A and also in A complement? Basically, we don't have n, so meaning that's why it was empty set. But in this case, we are saying A union A complement, A union A complement, meaning putting together element inside A and element outside A. It will be, what is in A? We have 1 and 2. Outside A, we have 3 and 4, meaning we are now trying to put in together everything, including elements inside A and elements outside A. So the single statement that we should get from this is that A union A complement, the answer is basically universal set. So it can also be written using or using letter U. Okay. So A union A complement is basically universal set. Then symbol number or property number 4 is that we have A union E. So in this case, we are trying to find the union, meaning putting together set A and B, the universal set. So we already have it. So our universal set is basically, if we use this one, our universal set will be 1 2, 3, and 4. Then our set A will be what we have there, which is 1 and 2 in this respect. Now, if I were to find A union E, what would be the answer? Meaning we are trying now to put together elements in the universal set and elements in set A. So if I start with a set, in set A we have 1 and 2. What do you have in the universal set? 1 and 2, which we have already written, and then the addition will be 3 and 4. Meaning that A union E is basically set E, everything, because what the element that we have here is what is containing in the entire universal set. So A union universal is basically universal set. Hopefully we are together. So hopefully everyone is following, and yeah. So number 5 is where we have A intersection universal. Okay, so A intersection universal. What should be the answer if we have A intersection universal? So from what we have here, this is our universal set, which we have here, and this is our set A. Now we are trying to find the elements which are found in both set A and the universal set. So from the intersection symbol, meaning we are trying to find the elements that are in both set A and the universal set. So we have 1 here and 1 in the universal set. We have 2 in the set A and 2 in the universal set. We have 3 in the universal, we don't have it in set A. We have 4 in the universal, we don't have it in set A. So if we check it properly, the only element which appear in both universal and set A is basically 1 and 2. And 1 and 2 are what we call, it's basically the set A. Meaning if we intersect any set with the universal, the answer is that same set. And also, if we try to union any given set with a universal, the answer is basically universal. Then if you try to intersect any set with a universal, the answer is always that same set. So A can be any set, could be set B, it can be set C, it can be set D, it can be set whatever set. As long as we intersect it with a universal set, the answer will be that same set. So these are some of the properties that you need to know. Yeah. So you can let me know if we are together so that we bring in another important concept that you basically need to understand. So okay, so number 6 property that you should know basically now has to go with the complement one. So we need to have the good understanding of the complement property. So under complement property, we have we can have this. So if I have A complement, I have 2 complements set A. What will be the answer? Can someone type up the answer? If you have A complement, what could be the answer? Quickly type up, just quickly. We move. A complement, what's the answer? Okay, good. Set A. So double complement always becomes just set A. So I gave you a good example of this one, that if set A were to be a person, like maybe a man, if you're dating 2 girls, we have chances of losing all of them, then you become single like this. So same, if a set is having 2 complements on top of it have good chances of losing all the complements and become a single set. Yeah, so you can try to do that to help you remember such a things. Okay. Yeah, so the other one under the same complement, so this could be our A. Then our B under complement is what we have. If I have A union B, and then I put a complement outside. Now, we know that, and this is the beginning of the De Morgan's law. If you have a complement, if you have two sets inside brackets and a complement outside, this complement meaning that it belongs to set A and set B. So now, what happens to the symbol in between the two sets inside the brackets if we distribute the complement to the individual sets inside the brackets? What happens to the symbol in between of the two sets? So we should know that when you distribute, okay, I think let me just say it. When you distribute the complement which is outside the brackets to individual sets inside the brackets, the sign in between changes. So in this case, we have got union, meaning it will become a complement. Union will become intersection, then B complement. In the same case, if this was A intersection B, and then complement outside, it will be the same. Meaning, taking the complement from outside the brackets to individual sets inside the brackets, what's going to happen that you're going to have A intersection, the symbol has to become union, then B intersection. So meaning, the complement, when we distribute the complement to individual sets inside the brackets, the sign in between the two sets basically changes. So if you have intersection, it will become union. If you have union, it will become intersection. Okay, good. Good. Yeah. So I think we can move. So these are the basic principles that we have to know for you to be able to prove or rather simplify sets. One, we should have a good understanding of laws of sets, specifically the distributive law. At the same time, you need to have a very good understanding of the properties of sets. Okay, so let's now do some exam questions so that we see how we simplify sets. Then after that, we're going to talk about the disjoint sets and the subset. Yeah. Okay, so the first example that we have is that using the associative, so I'll say exam question. So the question is that using associative and distributive properties of union and intersection of sets, full stop, show that so now here we have a lot of questions. So we are sure that our question one is that to be what? Show that A is equal to A intersection B, then union A intersection B complement. Yeah, so we do this one, then what's going to be our B? Okay, so B is that, again, we need to show that A union B is basically equal to A complement, then intersection B, then union A. Okay. Then C, we need to show that A union B is equal to A intersection B. Then that will be union A intersection B complement, then union A complement intersection B. So after this, we'll give another more examples so that we can perfect this. So solutions. So to answer all these questions, you only need to have the good understanding of the properties and the laws of sets. Just two things that you need to have a good understanding of. So you should know the properties and the laws of sets. Okay, yeah. So if you go for A, they want us to show that A is basically equal to A intersection B, then union A intersection B complement. Okay. So you have to be careful with the complements and the signs that has been given. So to prove, or rather to show, we always use the complicated part. So we can't use A to show that it's equal to this. But we need to simplify the complicated part. If we end up getting A, meaning we have shown that A basically is equal to this same set here. So if we focus on what we have to the complicated part, we have A intersection B, then union, then A intersection B complement. So we have to think of one, which property can I apply here? Two, which law can I apply here? That's a thing. And in most cases, what works is basically distributive law in most of the questions. So that's why I told you that never should you forget the distributive law of sets. So we need to have a good understanding of it and also the good understanding of the properties of sets. So if you look at it, there is no a direct property that we can apply here which can work out. So you have to think of a law of a set that can be used. So we have A intersection B union A intersection B complement. So this is basically distributive law of set. If you have to remember very well, we had A intersection B union C. It was giving us A intersection B union, then A intersection C. That was our distributive. Another one was A union, then B intersection C being equal to A union B, then union, basically intersection, then A union C. Yeah. So between the two distributive, then what we have to focus, because this is what we have is similar to what we have this side. So we check between this one, number one, and number two, which one is similar to what I have here, so that I can try to convert this one to other expression so that I see now where it can work out. Okay. So we can tell that we have A intersection B here, A intersection B. So the intersection is here, the intersection, the union, meaning this one qualifies because this one is carrying intersection between the sets, which is basically different from what we have. Okay, so now let's come back to our question. So our question is basically A intersection B, then union, then A intersection B complement. So I have to check what is common between A intersection B and A intersection B complement. Basically, the common thing is A intersection and A intersection. So we can try to factorize the A intersection. So if you take A intersection outside, we are going to get this, meaning we have already removed A intersection in the first set or in the first segment. What is left here? What is left here is basically a B. Okay? Then what's a separating symbol between this segment and this segment is the union. So you put your union here. Again, we come here. We have already factorized the A intersection. It is outside here. Meaning that what's remaining here is basically B intersection. Okay? Now, this is what we have. We have to think deep again. Remember, we have some properties of sets where we had A intersection B intersection a complement. We said is empty set. Then we had A union A complement. We said this was an universal set. What if I have B union B complement? It's the same universal set because B and B are the same. So you finding a union between any set with its complement, the answer is basically universal set. Meaning where we have B union B complement, we can replace with the universal set. Meaning we are going to have A intersection universal set. And then if you remember well, we also had the property that was A intersection E. The answer was that if you're trying to find the intersection between set A and set B, or set A and any universal set, or rather universal and any other given set, it will be just that same set. So meaning here A intersection universal, the answer is basically A. Meaning we have shown that here, they say show that this particular thing is equal to A. Meaning we have shown here. So basically we are together so that we go for the next question, which is this one here. Yeah. So are we together so far? Okay, so this is what we have calculated. So it's about understanding the properties and the laws of sets. So now let's go to question B. So our question B is we want to show that A union, then A intersection, then A complement, intersection B is equal to A union B. Okay. So this is so simple, meaning they want us to use this concept to show that it's equal to A union B. So always we use the complicated part. So we know that between this part and this one, this is more complicated than this one, meaning we can use this one to show that it's equal to this. So we can have A union, then this is A complement intersection B. Yeah. So again, it's just to think of either a property or the law that can be applied here. So if you have to think, do we have any other property that I can apply to change anything here? Yet we don't have any that we can apply to change anything here. But what if you think of the law? So it's the same things here. I gave you these two things. So in this case, we have this side here. A union is outside, meaning it can multiply with what is inside the two sets. Meaning in the first case, we can have A union outside. It could be union A complement. So we have a complement here, like that. So meaning the separating sign between A complement and B is basically the intersection. Again, we come here, A union, then intersection B. Or sorry, A union B. So this is what we have. Meaning what we have done here is basically A is outside. We have multiplied A with what is inside the brackets, meaning A union, A complement, intersection A union B. And then we get this. Then we ask yourself, do we have any part where we can apply a property between this part and this part, where a property can help us to simplify that part? Of course, yes. If you say A union, A complement, what's the answer? It's basically the universal set from the property that we discussed. So universal set intersection A union B. Okay. And we said that intersecting any set with a universal, the answer is that same set. So here, A union B intersection universal set, the answer will be the same A union B. Meaning we have shown that again. So it's so simple if you just understand the properties and the laws of sets. Okay, so this is what we have. So we go to C. Okay. So our C is that we have A union B is equal to this is A intersection B union, then A intersection B complement union A complement intersection B. So they want us to show that this segment is basically equal to A union B. So always we begin with the complicated part. So if you have any question, ask before we proceed. Or if we are together, just say we are together so that we proceed. Or if you have any question, let me know. Or if you are together, just type up we are together. Okay, Joshua, we are together. Brighton, we are together. Okay. So I think we can proceed. Yeah, we can proceed. So we have this. We have A intersection B, then union A intersection B complement, then union A complement intersection B. So in this case, we have got three segments. So it's up to you. We can first work with the first two because we can't handle everything at the same time. Sets always we compare between two parts. So having three parts, comparing three parts at the same time, which will look complicated. So what we do, first focus on the first two items. When we combine these two, we get a single answer, and then we can combine it with the remaining part. So we can simply say that, okay, I'll start with A intersection B, then union A intersection B complement. Then you do this to show that we are first trying to work with the first two part. Then you say this side we have got union A complement intersection B, meaning we want first to combine these two together, and then we try to union with the remaining part. Okay. So if I have a question, you can basically ask then. So for part B, what if we try to factorize? Okay, so just a minute. Yeah, what if we try to factorize? To factorize which part? So here, this is already factorized, so we try to expand. So we can't factorize anything for part B, because this was the question for part B. Meaning, this is already factorized. So what we do is basically to expand this. We say, what is outside can multiply with what is inside the brackets. Meaning it's only an expansion that can work from here, because factorizing is basically taking out what is common between the two given segments or three given segments. That is to factorize. Meaning we're trying to factor out something. Okay? So that's the reason why if you have such a thing, what we basically can do here is to expand, because you have brackets here and something outside, meaning what is outside can go with the A and go with the B inside the bracket. Yeah. So that is what we do. Yeah. So we should be very, very careful with the terms. What's the meaning of factorize and what's the meaning of expand? So to factorize is to take out what is common. To expand is to multiply something outside with what is inside. Okay? Or comparing what is outside with what is inside the brackets. But to factorize is to take something outside the bracket, from inside the brackets to outside the brackets. Hopefully this is clear now. Okay. So let's now answer our part C. So our part C is very interesting. It's very interesting. So here we can focus on this one first. So now here we can factorize. The person who was talking about factorizing, this is why it can be applied, because we have something common between the two segments. Here there is nothing common between outside and inside the bracket, so nothing to factorize. But if you check here, we have got A intersection and A intersection in both segments. So meaning it can be true to factorize A intersection. Okay? So if you factorize A intersection, meaning here what we are applying basically is distributive law. So we can factorize this, we can get A intersection outside, then you do this. If we remove A intersection here, what is left is basically B. So we're going to have B here, then the separating symbol between this segment and this segment is the union. So you put in your union set here, union symbol. Then we come to this segment. A intersection is already outside. So meaning what is left here is basically B complement. Then you do that. Then we know that we are working with this one first, and then we're gonna pair it with what we have to the other side. Okay, so we should be careful with what's the meaning of factorize and expand. Now we look, do we have anywhere we can apply a property? Of course, yes. We have B union B complement. So if you remember very well, we had that property where I said A union A complement was E. So A and B, A can be B. So we can have B union B complement. The answer should be universal set. Meaning the union between a set and its complement is the universal set. So meaning in this case we are going to get A intersection universal. Then we can do this to show that we are working with this one here, and then we say union A complement intersection B. But what is A intersection E? What is A intersection E? Okay, so A intersecting any set with its universal, the answer is basically that same set. Then to be union, we have this part here, which is A complement intersection B. So then we have to ask yourself here, can I apply any property here to simplify further? Or I need to apply a law? So what do we need to apply here? Can someone type up? Can we apply any property or we need a law? Okay. So what we have here, if you look at it well, there is no difference with the question B that we have solved. So in the exam, they tried to solve this one for you. They solve it and end here, and then they ask you to complete. That is in part A. In part B. So for part B, it's all the same question. Then it was solved. They reach at this point and then leave it there and ask you to finish it up. So it just requires your thinking and the understanding of properties and the laws of sets. So we need good. So here we need to expand now. So meaning we have A union outside and then A complement intersection B inside the brackets. Meaning that A union can go with A complement at the same time A union can go with set B. So what can we get from here is that A union, it go with the A complement. And then we need to know what is the separating sign between A complement and B. It's basically intersection. Then again we come A union, which is a common one, A union B, like that. So meaning we can go back to this one, because if I were to factorize A union, we get back there. So it might be something when you are solving, make sure that you're able to prove that, to go back where you're coming from. Because I've moved from this one to this point here. And I'm able to go back, meaning what I'm doing is correct. Yeah. Okay. So A union A complement. What's the answer? This is basically universal set. We know that. Then to be intersection A union B. Like that. So if this is what we have, we all know that what is intersecting n set with a universal? The answer is that same set. So universal set intersection A union B. Our answer will be A union B. Meaning we have shown that they say show that A union B is equal to this. Meaning in this case we have shown you get your 5 marks here and your 5 marks there. So these are the questions you expect to see in your test 1. Make sure that you understand them very, very well. Yeah, understand them very, very well. So before we go to the disjoint sets and subset, let me do another example on simplifying sets, which will be the last example, so that we go to the last part of today's session. So the question is here. It's also an exam question. Okay, so question is here. So the question that given that x and y are basically a subsets. Okay, a subset of some universal set of some universal set, which is basically U. And then full stop. Simplify the following. So the question that's simplify the following. Simplify the following. So A, we have A intersection, then X complement union Y. I gave you this question in your assignment. Most of you made a lot of mistakes here. Yeah. So, and then B, we have open bracket, which is a square bracket, then smooth bracket here, then we have intersection Y, and then smooth complement, then next thing we have intersection X complement, then union Y, then we have again square bracket, the complement outside. Okay. So this is what we have. Given that X and Y are subset of some universal set, simplify the following. So first thing we have to simplify what is, okay, so this is X, not A. So just for correction, this is X. Okay, so X intersection, open bracket, X complement, union Y. Then B, open bracket, which is square bracket, another smooth bracket, and then X intersection Y, close bracket, complement, intersection, then open bracket, X complement, union Y, and then complement, open close bracket, close another one, then complement. Yeah, so same things. All you need to know are the laws and the properties. So solutions. So we pick our A. So our A is basically X intersection, then X complement, union Y. Okay. So first question you need to ask yourself is that is there n? This is how it is, or there is a complement outside? Yeah. Okay, so okay, yeah, it's like this. Good. So this is what we have. So one thing you should ask yourself that, is there any property that I can apply, or is there any law that I need to apply to simplify this? So in this case, do we have any relation between X complement intersection X complement union Y? It can be equal to what? This is if we have something like this, it's as good as X complement union Y is basically equal to X complement union Y. It can't be simplified further. Meaning there is no any other law that support that if you have two different sets, X complement union Y is equal to the same things, because X and Y are not common. So we should have a good understanding and to differentiate if I have X union Y union X complement, where we say this is universal, or in situation where I have X, maybe intersection X complement, where we get an empty set, and in the situation if I can have Y intersection Y complement to be basically empty set, and in the case where I can have Y union Y complement, it could be the same universal set. And in the case if I have X complement union Y, this is equal to the same thing. So we can't simplify two different sets. These are different. In the same cases, if it was X intersection X complement intersection Y, it would be the same things, because the two sets are not the same. So there are one thing you should understand, that these two should be the same, like Y, Y, and then we have a complement somewhere, or X, X, or A, A, or B, B, and all that. By the moment they are different things, you can't simplify further. So let's come back here. Yeah, so since inside there's nothing that we can simplify, so we have to think of a law that we can apply. So we need to try to expand this into the expanded form of distributive. So this can be X intersection X complement, which is inside here. We put brackets. Then separating symbol is union. Again, X intersection outside, then Y, which we have there. Okay, meaning this is what we have done here. We have just converted this one to the expanded form of distributive law. Then we have some ideas of what is X intersection X complement. So intersecting a set with its complement, the answer is basically empty set. So to be empty set union X intersection Y. Now we are trying to union. Let's try to add 5 things plus nothing. We get the same 5 things, right? If I say this is as good as 0 plus 2, the answer is basically 2. So we have X intersection Y combining with nothing. We get the same thing that we have, because we are trying to add nothing to X intersection Y, okay? Because we know that union is putting together. So putting together X intersection Y plus nothing, we get the same thing as X intersection Y. So meaning the answer here is basically X intersection Y. Meaning you're done like that. So hopefully we are understanding something. So this is what we do. So we can go to part B. Yeah, we can try part B. So we move on to part B. Let me know if we are together, so that we move to part B. Can you be fast? Can you be fast? Can you be fast? Just type up if we're together. If you are getting me, yeah, let me know so that we move. Yeah. Okay, good. Brighton, good. Moses, Matthews, Mope, okay, good. Jerome, alright, but Jerome, you should be coming for physical classes. You don't come in class, where have you been? Okay, so, let's solve question B now. So question B is where we have square bracket, then open smooth bracket, X intersection Y, then we have complement, then intersection, then that X complement union Y, then that square bracket complement. Yeah. So whenever you're trying to ask something, so you guys, you have to know that sometimes these things can help you to body mass, such that sometimes these things, they look like they are old and you learned them back then from secondary and all that, but still their application, they're still in place, and yeah, with an educational value. Okay, so here we have two types of brackets. We have, this one is called square bracket, meaning it's called square bracket. And then this one is called smooth brackets. So we first have to deal with what is outside. So for me, I always tell myself that sometimes you cannot, if you have never eaten a sweet and then I give you, if you can't remove the plastic outside and then you tell me that this one is very sweet, meaning we have eaten it before, we are lying. So in the same case, you can't enter inside the two things without removing the first bracket. Meaning, this one we have got an offense, or rather the gate. There is a gate. Those who are coming from, yeah, you know what I mean. The houses which have got a gate, or rather a offense, and then there is a gate, and then inside we have got the house and the doors that we basically use to enter the house. So if someone is coming here, that person cannot open this door, which is for the main house, without opening the gate. If the gate is closed and someone is there, meaning that one has to be a witch. They must be, first someone has to be open the gate, and then you open the door for the main house, then you enter inside the house. So if I find you are trying to answer this question, then you go direct, try to work with the complements inside the set without working with the one outside, meaning what you are doing is basically wrong. So always start from outside. We need to enter, to remove these walls so that we enter inside and work from there. So that's the main principle that we have here. First, remove what is outside, and then we can work from inside. So that's what we do. Yeah. So let's now solve this particular question. So what we have is this, then x intersection y, complement, then intersection, x complement, union, y, then square bracket. So like I told you that we can distribute this complement inside these individual segments of sets. And we remember the one property that I told you that if we have A union B with a complement outside, so taking the complement inside to individual sets basically changes the sign in between them. So this can become A complement intersection B complement. This is very important to remember. So, so here we can take this complement to this segment and this segment. So we're gonna get this to be x, open bracket x intersection y. We have the complement which is already here, and then if you bring this one, you're going to have 2. Then, because this complement now has entered inside these two segments of sets, what happened to this sign? So we cannot change this sign inside here because the complement has not yet entered inside these ones, but it's entered inside the square brackets. So the only symbol that should change is this one here to become the union. Then we get that x complement which is already there, then union y, and then the complement outside. So the complement in red is the one that we have gotten from outside. And it's the same complement that has changed the sign between this segment and this segment. We had intersection initially, it has become union because this complement has entered the two segments of sets. Yeah. So, yeah, okay. So A intersection Y. We have complement. If you have two complements, they cancel each other. So this side we are going to have X intersection Y and then complement, like, oh, no, sorry. We're going to have, without a complement, yeah. Then union. Here, we can take this complement inside because it's only one, there's nothing to cancel with. So it can enter inside here. So we're going to have x complement. Okay, then what happened to the symbol between these two sets become intersection. Then y, and then complement here. Okay. Again, we have to apply a certain property. Two complements can cancel each other. So this one will become x intersection y, then union, and then this will be basically just x, then intersection y complement. So in this case, we can see that this is similar to distributive. So what do? We have something in common between the first segment and the second segment. What is common here is x intersection, meaning we can factorize x intersection outside so that we get the factorized form of distributive law. So we can say that since x intersection is common, I can take it out and do that. So what is remaining here is basically the y. The separating symbol is basically union between this segment and this segment. Then what is remains here is basically the y complement. Then we have that. But what is y union y complement? These are the same sets. So y union y complement is basically universal set, right? So this will be x intersection e. So meaning our final answer is basically x. Meaning yeah, we have 5 marks here as well. So this is how we solve mass simplification of sets. Yeah, so if you are following, if you are together, just type up so that we move to the next concept now. So just let me know that we are together from the time we started up to this time. Okay. Yeah, so let's maybe do one example on these same things. So the other question that I want us to go through is this one. Let's check it out. The question is that we need to simplify this set. So the question is that simplify x complement union, then open brackets, this is y, then the intersection z, then square bracket complement. Yeah, how can we simplify this? So this one is basically simple. So like I told you, if you look at what we have inside, there's nothing that we can apply, and of course we have got square brackets. So always deal with what is break the main offense from the equation. So we have to remove the square bracket, and then we can see what we can do from inside. So first thing, we have to distribute this complement to both individual sets. So this one, we're going to have x complement. If you take this complement in, you're going to have 2 there. The sign here will change to intersection. Then open bracket y intersection z outside. So have you seen that this sign is not changed? Why? Because the complement has not yet entered inside the individual sets. It has entered inside the square bracket, so it changed the sign because we distributed to this part and this part. So the sign between this first part and this part is what should change. Now we have 2 complements, meaning they can cancel. Meaning you're going to have x intersection. Now this one now can enter inside these 2 things. So we can have this, then we're going to have y complement. This one now will become union, right? Then z, like that. So when you are here now, you have to ask yourself, what is y complement union z complement? There's nothing that we can simplify further here. So this has to remain like this, because we don't have any other information about these 2 sets. So this can remain like this, because if you try to simplify further, you say what is common could be X intersection Y complement, then union X and then intersection Z complement. This will be not the final, the factorized for, because we still have something common. You can still factorize X intersection with X intersection, then we will get X, Y complement, and then union Z complement, which is the same as this one here. So the best point to end is basically here. This is the best point to end. Because if you go back to this one, if you take to this one, meaning you still have something in common that you can factorize. And if you factorize it, it will take you back to this same statement. So you cannot go further. You end there. Yeah. So the other statement, maybe that you basically, okay, fine. Now let's go to, so I'll give you the work at the end that you can go and practice, or rather I'll share in the group that you can practice about these things. So, let's move to the next concept now, which is very, very important as well. Okay, so let's talk about subsets. So subsets. So we have subsets. So like we said, a subset is a set within another set. If I say B is a subset of D, what I mean here, if I were to draw the diagram, I mean this way. If this is my D, then this will be our B. Meaning the first set is the minor set, the second set is the major set. Okay, so if I say B is a subset of D, they mean B is the one which is inside set B. B is the one which is inside set D. Yeah. So set within another set. So let's do a question now here. So exam question. So the question is that if C is a subset of, okay, the question is here. So if C is basically a subset of D, then simplify if possible. Okay, so simplify if possible. So our A is basically C intersection D, then B is C complement union D complement, then C is at C union D complement, then our question D is basically C complement intersection open bracket C union D. So the question that if C is a subset of D, then simplify if possible. So you have A, B, C, and D. So you have 4 questions. So solutions. So our A is at C intersection D. Now if C is a subset of D, meaning here our minor set is basically C. So C is basically our minor set. And then D is the major one, the major set. So what is C intersection D if C is a subset of D? Meaning here all elements that are in set C are also in set D, but not all elements that are in D are in set C. Like I gave you the thing about intersection subset, meaning that what we have basically is that this is the major set and another set inside. So this is our C, this is our D, meaning C is inside. So the intersection between this, if here we have one element which is 1, then 2 and 3. what's the intersection between C and D? It's basically 1. So meaning intersecting a set with its major subset, the answer is that's the minor set. So the intersection between the major subset and the minor set is the minor set. So meaning our answer here is basically just a C. Yeah. So intersecting a major subset with a minor subset, the answer is the minor set. We should know that. Now we go for part B. So part B is where we have C complement union D complement. So we know that if you approach it in this way, we can't simplify this one further. But we need to try in which way I can change this one so that it makes sense for me to simplify it. We know that we can try to factorize the complement here. We apply De Morgan's. So this one is basically we apply the De Morgan's law. So we'll do De Morgan's law later. But we need to apply the De Morgan's law where we try to factorize the complement. Let's say we're going to have C can become intersection D, complement outside. Remember, if I were to take the complement inside, the sign will become union here, and then we can get back to this. So we have changed nothing between these two things. What I've done basically is applying De Morgan's law where we factorize the complement and get this, the sign between changes. So that if I were to take the sign inside, we can get back to our original expression that we had initially. So this one can become, this is what we have like here. This is the minor set, a major set. So intersecting between a major subset and a minor subset, we get the minor subset with a complement outside. Now we can take complement in and get that. Nothing we can simplify further. So C complement intersection D complement, where C is the subset of D. We can take it in this way applying De Morgan's law. And then we know that C intersection D is basically C because C is the minor set of D. Then we have the complement outside. You can just take it there and then end there. Yeah, so this is what we do. Now let's go to part C. So our part C is where we have C union, basically D complement. So this is interesting. Where C is a subset of D, there's nothing that we can simplify further here. Because one, we have got no direct relation between, so we are trying to find the union between C, where C is a subset of D. Then what could be the union between set C and element outside set D? Is the same things, expression. So C union D complement. It's the same as C union D complement. So this one is just basically equal to, it can't be simplified further. Union D complement. You cannot simplify this further. So this is the simplified form of this expression. It can't be simplified further. Now we go to the most interesting one, which is D, where we have C complement intersection, open bracket, C union D. Yeah. So this one is basically more interesting, and make sure I pay attention to this one and this one. Yeah, this one can come in your test ones. So make sure you basically pay attention. Okay, so this one is so simple. So you have to think, do I have any property which I can apply direct, or I need the law? So this one we can apply distributive. If you can look at properly, distributive. Distributive law can work from here, where we can say C complement intersection can go with a C. Again, C complement intersection can go with a set D here. So we can get C complement intersection C. We do that. The separating symbol is basically union. Then C complement, then intersection D. Yeah. Then we know that what is C complement intersection C? What is C complement intersection C? Is basically empty set. We know that, right? Because we are trying to find an intersection between a set and its complement. Then to be union, C complement intersection D. Now, if you ask yourself that what could be the combination of nothing plus C complement intersection D? If you combine the two sets, nothing plus what we have here, what do you get? We get the same things here, right? The answer will be C complement intersection D. So meaning here we get C complement and then intersection D. Yeah, then you see, is there any property that we can apply or any law that we can apply here? Basically, one, we don't have any law that is direct you can apply here to get something different from what we have. Secondly, we don't have any law that supports these things that which can be equal to something. So it can only work if this was C complement, maybe intersection C. We have a property that can apply here, but this is C complement, then intersection D. Set C and D are two different things, meaning these are unlike sets. So they can't have a direct relation that we can apply here, meaning this will end there. Can't simplify further from it. I mean, this is a simplified vision of these things here. So this is about subsets. Yeah. So before we go to disjoint sets, do you have anyone who still have challenges with what that we have discussed so far about a subset? Or let me know if we are together so that we move. So are we together so that we talk about the last part of today's session, then we can call it a night. Okay, so can we move further? Are we together? Okay, good. Brighton, we're together. Okay, so let's do the last part of today's session, which most of you requested that you need to have a good understanding of disjoint sets. So we can move to disjoint sets. So disjoint sets. Okay. So by definition, a disjoint set is the sets that has no intersection. So if set A and B are disjoint, it means that there is no intersection between set A and set B. So in diagram form, they are presented like this. We can have the Venn diagram like this, Venn diagram. Then you can have set A and set B. Meaning these two sets are disjoint, meaning disjoint. They are not joined together. So to be disjoint means they are not joined together. Because initially we draw sets like this, meaning there is an intersection between A and B. Okay, but look here, there is no communication or connection between B and A and set A and set B, meaning these two sets, they have got no intersection. So if they ask you what is a disjoint set, what should come in your mind that these two sets, they don't have intersection. They are independent of each other. For example, maybe set A, we have element like 1 and 2. Then set B, maybe we have 3 and 4. So if we are to draw the Venn diagram for such set, we are going to make it like this way because we don't have any element in A and in B. So we're going to have that to come like this way, and then you put your set A here and your set B here. So set A and then you put your 1 and your 2 here, then you put your 3 and your 4 there. So it will be like this, meaning these two sets are disjoint. So it's a main thing to understand that disjoint, no intersection. And then aside, we know the properties and the laws of sets. The rest is basically very simple. Okay, so someone's question to repeat. I repeat which part? About disjoint. So I'm saying disjoint from definition, these are sets that have got no intersection between them. Example is the one illustrated here. And then diagrammatically, they are represented like this. I even give an example of set A and set B. Then we can write them in this way because we don't have any common numbers in B and in A, meaning these two are disjoint. Okay, so that's what we are talking about. Now, let's do some exam questions. Okay, so exam questions be here. So the question that if C and D are disjoint, if C and D are disjoint, then simplify the following. Simplify if possible. Simplify if possible. So A, we have basically C plus. Oh yeah, so we can try to solve those network problems. Okay, we are ending soon. And you can watch the video at your own time again. Yeah, good. So we can apply De Morgan's here. We say this can be A intersection D, then complement outside. Okay? We factorize the complement. Now, C and D are disjoint. So disjoint meaning we have set this set here, another set here, and then you have an universal set inside. This is our C, this is our D. So if I may ask you, we should know that disjoint sets, they have got no intersection. Their intersection is basically meaning C intersection D is empty set because these two sets, they are disjoint, meaning they have got no intersection. What does this mean? Meaning that their intersection is empty set. We don't have any element in A found in D and in basically in C. So meaning the intersection between set C and D is empty set. So we have this statement here, and then we have converted to other form of De Morgan's, and we get this. Then at this point, we try to check what is inside the brackets. What is C intersection D if the two are disjoint, meaning it is empty set, right? Then we have a complement outside, which is there. So this complement can come in. We get empty set complement. We have this property where if we have empty set complement, we should know that it's called a universal set. Very important property to know. Okay, so this one we can get a universal set, meaning we are done from there. So this is how we have simplified. We have this, just try to apply De Morgan's, then you take out the complement, you try to find what's the relation between C intersection D. If the two are disjoint, they're going to have an empty set, and then empty set complement, we get universal set. Okay, now let's go to part C. Okay. So part C is basically the simplest one because I've already simplified it. So part C is basically C intersection D and then the complement outside. So this is more like what you have from solving. The two are disjoint, meaning they don't have intersection. So meaning that intersection between C and D is empty set, then brackets there. So the complement can come inside that way. And we know that empty set complement is basically universal set. So this one you can get, it is E. We end there. Very simple stuff. Yeah, so now we come to the last one, which is D. So for part D, we have what we have is that D. Oh, sorry, we have part D. We have C union D and then complement. Even if we try to convert to other form of demogram, C intersect complement intersection D complement, nothing will make sense. So meaning this one cannot be simplified further as well, because even if we take it back here, it will require us to factorize the complement, because complement we're going to have two of them. If you factorize, we get back to the same things. So meaning you'll be just be moving at the same thing. We go there, we come back here. Nothing will change out. Now to be like a circular things. So C union D complement is equal to the same things. Can't be simplified further if the two are disjoint. So meaning this is what is all about, those disjoint sets you basically requested for. Yeah, so I think for today we can end here. So what we do basically that you go on the website and start the documents there. And those that are not part of our team or exams made easy, we can basically call us or rather text on WhatsApp 0768 790499. If you want to join us, just text on this one, how can I join? Exams made easy, and then after that we'll respond to you as soon as possible. So for today we can end here. Find time to watch the video at your own free time. So what is remaining under sets that it's just the Demogran's law. So make a day where we're going to talk about Demogran's proving and all that. Yeah. So that all those that are basically joined us, let area they can catch up so that we move together. So if someone have got a question, they can ask, but this is where we end. So before I finish the video, ask a question if you have any. Yeah, so for today we end here. What is left basically is just proving the Demogran's law. So these are the main things we need to know about sets. One thing you need to have a good understanding of, like I said, you need to have a good understanding of one, properties. Then number two, laws of sets, specifically distributive. Then, and also the good understanding what is the meaning of disjoint, and also good understanding of subsets, and something like adjoint. So we talk about adjoint when we do Demogran's law. We'll put it there so that you can also have some understanding. So properties of sets is very important, and laws of sets. If you know the two, you can simplify any set given. Then have understanding of adjoint and of disjoint and the subsets. So we have the website where we have documents there in of chemistry. So in CH110, PH110, then by BI110, and basically MA110, the one of I'm doing. So we can text us so that we see if you want to be part of our group. So 790499. So that will be text from WhatsApp so that we can be added to the group. So for today, we can end here and have a good night.